2 gallons of pure antifreeze to obtain a solution that is 70% antifreeze. So we have to take our solution, we're diluting it down, and we're trying to get a 70% concentration. So, we have a couple different things here. We have water, we have antifreeze, and we have our mixture, right? It can be confusing on these problems, trying to keep everything straight. So my suggestion, when you have problems that involve a lot of different things, is to set up a table. My rows of my table are going to be the things that I'm mixing together. Okay, in this case, it is, I'm taking water, antifreeze, to get a mixture. Now, I want labels there because this is how we are defining our variables by using this table. So you have to tell me what your rows stand for, but they don't have to be super specific. If you want to call it the first thing, the second thing, and the total, that's fine, but you need to have some kind of label there. Now across the top, we are going to put a formula. So we have to figure out what formula makes sense here. And it's not one that you are used to using, but it's one that we might be able to figure out. Okay, when my kids were little, I was that mean mom. I wouldn't let them have full strength apple juice because I thought it had too much sugar in it. So I always diluted their apple juice with water. Okay, so let's say if I had a gallon jug of apple juice and I added a gallon of water to it, how much was in my final mixture? How many gallons? 2 gallons. How much of that was actually apple juice? 50%, 1 a gallon, so 50% was apple juice, okay? What if I had a concentration, and let's say I told you I had 4 gallons, and it was 25% apple juice. Can you tell me how much actual apple juice I added to that? 1 gallon. Makes sense, right? 4 gallons, 25%, so you probably just divided by 4. What happens if you take 4 times 0.25, the 25%? You get 1, right? When with my 2 gallons, if I take 2 times 0.5, the 50% apple juice, we get the 1 gallon of apple juice. So that's our formula that we're using. We're going to take the amount that we have. And you can abbreviate these, I probably will after the first one, times our concentration. And that equals our amount pure. How much actual apple juice was it? So if I took the number of gallons of my mixture times the concentration, I get the amount of pure apple juice. When we do these mixture problems, that's the formula we're doing across the top every time. Are there any questions so far? Now, we are just going to fill in the gaps on this table. So it starts out, how much water? So if I look, the amount of water, do I know it? No, so what do I write? X. I don't know the amount of water, that's my X. Should be added to 2 gallons of pure antifreeze. So the amount of antifreeze I have, 2. Okay. To obtain a solution that is 70% antifreeze. All right, where would that 70% go? It's a concentration. Is it concentration of my water, my antifreeze, or my mixture? The mixture. Since it's a percent, you always change it to decimal form. So 0.7 or 0.70. All right, if you go fill up your cup at the water fountain, what percent antifreeze is that? 0, we hope, right? Water should not have antifreeze in it. We're talking about our concentration of antifreeze. Water has no antifreeze in it, so that's 0. I am mixing it with pure antifreeze. What does pure mean? 100%, so in decimal form, that is a 1. All right, what's still in our gaps here, my mix. If I put in 3 gallons of water and 2 gallons of antifreeze, how many gallons do I have? 5. How'd you get it? Add them together. So if I have X and then I have 2, my mix is X plus 2. Have I lost anybody? Now we have actually done all the hard work at this point. My final column was the equation. Amount times concentration. So what's X times 0? What's 2 times 1? And you could go ahead and multiply this out. I'm just going to write it here, so if you look back at your notes, you know what we did. We're going to take 0.7 times the X plus 2. So this is my amount of pure antifreeze. So here's how much water antifreeze was in my water, how much was in my pure, and how much is in my total. The equation is the same every time. You add the 2 things you're mixing to get your total. So when I'm mixing, my equation is just this column. So we have 0 plus 2 equals 0.7 times X plus 2. Can we solve that equation? Distribute your 0.7, subtract over the 1.4. If you divide your 0.7, you get a not very nice decimal, or 6/7 if you write it as a fraction. And then what do we have to do to finish? Write a sentence. So if we look back, the question was, how much water? When I look, X is my amount of water. So there should be 6/7 of a gallon of water. What questions do you guys have for me there? You okay? Okay, I want you guys to read the next problem and see how much of the table you can set up. I don't want you to try to write any equations yet. I don't want you to try to solve anything yet. I just want you to read, draw a table, and put in the things you can. Has everybody read the question? What's the formula that we put across the top? So amount times concentration equals the amount here. All right, so concentration, that's always like your percent. Your amount is going to be like gallons or liters or something like that. So kind of some clues to help us. So this time it says, how many liters of a 25% antifreeze solution should be added to 5 liters of a 10% solution to obtain a 15% solution? There are a whole lot of percents in there. If I just look at the percents, let's say you didn't even read it. We have 25, 10, and 15. Even without reading the question, you should be able to pick out which of those is the concentration of the final mixture. Do you know how? It has to be in the middle. You're always going to take something of high concentration and something of lower concentration and get something in the middle, right? I can't take something that's 50% apple juice and something that's 20% apple juice and get 90%. That wouldn't work. If I mix a 50 and a 20, I'm going to get something in between those two numbers. So even if I don't read the problem, 10, 20, 10, 25, and 15, which one's the final one? The 15. Now you can use those labels here. Most people, when I was walking by, just called them like antifreeze 1, antifreeze 2. That's fine. I don't care what those labels are as long as they make sense. So if you want to call it first, second, and total, that's fine. It doesn't matter to me. But those concentrations are important. We know that my total is the 15%, so that's 0.15. So the others have to be my 0.25 and my 0.1. Okay. It says how many liters of the 25%. So here's my 25%. I said how many, so I don't know it, so I call that X. Should be added to 5 liters of a 10%. So the amount of my 10%. So what's my total? All right. How do I get this column? Amount times concentration. X times 0.25 is 0.25x. 5 times 0.1 is 0.5. Here I have my 0.15 times the x plus 5. And how do I get an equation from this? Add the first and second to equal the total. So 0.25x plus 0.5 equals 0.15 times x plus 5. So the point of this table is really just to organize the information so that we can come up with an equation. But if we use our table correctly, it really writes the equation for us. So now we just solve. So we have to distribute first. We need all of our x's on one side, so if I subtract over my 0.15x, need my numbers on the other, so if I subtract my 0.5. Alright, you guys tell me, does it bother you when I don't show my work on those? Do you know how I got there? If I ever skip a step and you need it, please tell me. Divide by 0.1. We get 2.5. What do we do next? Write it in a sentence. So the question was, how many liters of the 25% solution? And that's what X represented. So there must be 2.5 liters of 25% solution. Sense? A little different than what you're used to, probably. Any questions on what we did? The next one on here, I actually stole from Mrs. Brand's food science contest when I was helping them with some math one year. So, this one says, you have been tasked with creating an innovative dairy beverage. You have 30% heavy cream and 3.5% fat milk. Your target dairy product should have 7% fat. Since this is a test batch in your product development lab, you will be making an 8-pound batch. How much heavy cream will the batch require? Where do I start? Make a table, yes. What formula goes across the top? When I see those percents, I know it's a mixture, so I'm doing my amount times concentration. Equals amount here. You really have to have those labels on your rows and columns, otherwise it doesn't technically define the variables for me. Okay, I sometimes have people that just want to set up the table and not label. Then I still don't really know what X is, so you need those labels. Alright, my rows, you can call them as specific as you want. If you just want to call it first, second, and total, I'm fine with that. Can I pick out, if I'm looking back, just look at your percents. Which one has to be the final concentration?
The 7%.
7% has to be in the middle of the other two. Percents, we always change to decimal form, so 0.07. Then the other two, you can put in either order. So we have the 30%, so that would be 0.3. The 3.5%, so 0.035. So now we go back to the problem, look for information. The only other number it tells me is I'm making an 8-pound batch. What's the 8 then? That's my total one. So this is a little bit different. I don't want multiple variables here. So I can't say they're X and Y. I don't know how much of the first one, so you can certainly go ahead and call that X if you want. But now we have to figure out what to put for the second. So my suggestion when you get stuck is just to think about it. If I have 1 pound of the first one, and I need 8 altogether, how many more do I need?
8 minus X.
You need 7 more pounds. You got it by doing 8 minus 1. So it's just the total minus the amount we already have. That's the hard part. Now what do? Multiply. So X times 0.3. 3X. 0.035 times my 8 minus X. My 8 times 0.07. So you can certainly go ahead and multiply that stuff. I'm just trying to show you where I'm getting my numbers. I want you guys to go ahead and write and solve your equation from there. We know you just add the first two to equal your total. Does anyone need me to look at their paper? Didn't get this into. I didn't specify how many decimal places to go. The fraction 56 over 53 is obviously a little bit ugly. But what did my question ask me? How much heavy cream? When I look back, my heavy cream was the 30%. So I got lucky. That is what my X was. If it wasn't, if I'd asked you how much of the milk, what would you do? 8 minus the answer we got. So batch requires.
So do we go for 3 decimal places?
I didn't specify, so if you had. You just don't want to round. Like,
Okay. I think I did this one.
yeah.
So that's
So keep the decimal there, but then you can round your final answer. All right, what questions do we have on this? How much time do I have? Okay. Let's go ahead and do one more problem. And then I'll probably stop. So the last type, we have motion problems. So there's 3 main types. The ones we did last week, which were a lot of times ones we could draw a picture with. These mixture problems, which we're using our table to solve. And the last ones are motion problems or distance problems. So if I look at this, Russ and Janet are running in the Strawberry Hill Fun Run. Russ runs at 7 miles per hour and Janet at 5 miles per hour. If they start at the same time, how long will it be before they are 1.5 miles apart? So I have 2 different people running. What strategy did I just teach you when you had a lot of information? Make a table. Do you think we can make a table here? I don't necessarily have like first, second total, but I at least have 2 people that I can put on my table. So let's do that. So I may not need as many rows. Have my people. Okay, if I'm talking about speeds and distances, do you guys know the formula for distance? You take your rate, so your speed, times your time, how long you run, you get distance traveled. Remember D equals RT, distance is rate times time. Bless you. So those are really the 2 formulas we're using. The mixture ones and the distance one. Alright, rate. Russ is 7 miles per hour. Your rate is your speed. So Russ is 7 and Janet is 5. Okay, do I know the time? No, but what do I know about the 2 of them? Okay. They're going to start at the same time and they're 1.5 miles apart. So if I don't know how long they've been running, but they started at the same time, their 2 times are the same. They're both X. Okay, one person didn't start ahead of the other. So my distance, rate times time, is 7x and 5x. Alright, these distance problems we have to think a little bit more. Because there's really 3 different scenarios. You okay? You could have like 2 people that start at the same point but are going opposite directions. And so then if you wanted to get their distance apart, what would you have to do with those? Add them, right? If I told you this one was 7x and this one's 5x, their total distance apart would be 12x. Okay, sometimes we have where they start at the same point, but maybe one's ahead of the other. And I want to know when they catch up with one another. If they catch up, what's true about their distances? They're the same. So sometimes it may be a scenario where, okay, she started running, he started 5 minutes later. At what point does he catch up to her? Our scenario is they started at the same time. And they're running the same race, so going the same direction. If I want to know how far apart they are, what do I need to do with those? Subtract them. So because they're running the same direction, I have to subtract those to equal my 1.5. Now we just answer the question. It wants to know how long. What is x measured in? It's my time. Is that hours, minutes, seconds? It's hours. Because their rate is miles per hour. So that means my time has to be hours, my distance has to be miles. So it will take 0.75 hours or 3/4 of an hour or 45 minutes if you want to do that conversion. How do you convert 0.75 hours into minutes? Multiply by 60. So any of those options would be fine with me as long as it's equivalent. Okay. Any questions there? So you have a paper already. Last week we did, so hopefully you have already done 12 and 15. Today I want you to do '20s, 30, and 32. Tomorrow I'll do the last few examples, so this will be due Wednesday. Tomorrow I'm going to add 3 more problems.